Can you wait a minute? I think it's. Can you see my screen?
No, it just says that you started sharing screen, but I can't see anything. It's like blank.
It says it's paused, and I've tried to So when I screen share, if I share my screen, there we go.
I can see now. Yeah.
Yeah. So I want to start from the beginning because this log stuff is quite hard.
No, that's okay. We can do all this if you want. I mean,
yeah.
The one which you think is difficult. Yeah, let's do this. Yeah, so which one do you want to start with?
Just the top one.
Right.
The whole thing, really.
Yeah. So you have to find the exact solutions in the simplest form to the equation, right? So do you want to try or do you want me to explain?
So I like solve for x here, right?
Yeah.
So first I'll move the 10 to the other side. I stop 10. Okay. So I'll move that 10 to the other side. There's 2 ln 2x plus 1 equals 10.
Yeah.
Then we'll do ln 2x plus 1. Then we'll just move divide by 2 on the other side.
Yeah.
So it'll be 5 equals 5.
Yeah.
Then if we do 2x plus 1 equals e to the 5.
Yep.
On the other side. 2x equals e to the 5 minus 1. X equals e to the 5 minus 1 over 2. Yeah.
That's it. Yeah.
Okay. The next one is, so we solve for x again here.
Yeah.
Could we do, I'm thinking, if we natural log, divide by natural log. So we'll get ln 3 to the x times 4x equals 7.
No, I can't do it. I mean, you'll have to take the log on both sides here.
Okay.
Yeah. So take.
So shall I take the log and move the power to the front?
Yeah, like that. Yeah. So
for this first one,
you'll take log 3 to the power x, and e to the power 4x is equal to the log of e to the power 7. So on the left hand side, this will be log 3 to the power x plus, the property of log. So this log ab is log a plus log b. So this will become e to the power 4x, and therefore this will become 7, simply because that's natural log we take. Yeah.
Okay.
So this therefore become log x log 3, yeah.
Yep.
Plus 4x
log e.
log e, again that becomes 1. isn't it? Because log of log e is 1, and that is equal to 7. So simple, you can take x common here, and it becomes log 3 plus 4 is equal to 7. Your answer
Why is
would
log
be,
e 1?
yeah, because log e, natural log of the same thing, is always 1. Even here it is natural log, but even if it is not, so log of same number, let's say log a to the base a is always 1, isn't it?
Oh yeah, that makes sense. Okay, so that was 1.
So therefore x will become 7 over log 3 plus 4.
Okay.
Do you understand? So
yeah. How did we go from this to this? So do these cancel out, the e and the log?
yeah, because 4 actually so it's like a 4x e. Can we write like that?
Oh
Because
yeah,
there's a
of
power
course.
there, and then again this is 1. This whole thing is 1. So straight away I wrote like 4x here.
Okay.
Yeah.
Yep, got it. This next one. So we need to actually solve for x here.
Yeah, so here you have to find, and it says algebraically, so you can't use the graphical method here. But again, algebraically it's easy, graphical is difficult, so you don't need to say that. But yeah, you need to find x in this interval, in this interval between -1 and 2.
So if I just divide by natural log, ln.
No, we don't do that. No, look, ln is not any number or anything. So never like divide or multiply by natural log. Never do that. Okay, so just like we do like both side, like x or y or 5, 7, any number, anything you can divide, multiply, that's fine, because they are the number, they are the variables. Ln is just a function, type of function. So it's not like a number so that you can divide both side by ln. You can take ln of both functions. We say like that. So let's say if I have x equal to y, just say something like that. Okay. Now I can say, okay, let's take log of both sides. So I can say log x is actually log y. We can do that.
Yeah.
But you can't say like, okay, let's say if it is ln x is equal to ln x plus 4, then you can't say, okay, divide both sides by ln. Ln here, divide ln here, and ln cancel. No. Okay.
Okay.
Yeah. So here you'll have to look at the property of, properties of log is very important here. So if you look at left hand side here, there are two natural logs, they're adding together. So what you can do?
Times them.
No, not cancel. So it's like this. So look,
times.
Yeah. So it's like log A plus log B. If it is this, then simply you can write log AB.
Okay.
So that's a hint to you. Now you carry on from here.
So if we do ln 36 minus 18, so if I just expand those two brackets.
Yeah, you'll have to do anyway, because it will end up as a quadratic. So yeah.
So that gives me ln 36 minus 30x plus 6x squared equals 2 ln x plus 1. Okay, so I've expanded that now.
Yeah. So look, so the hint is, so whatever you got in the bracket, something. Now you've got 2 log or whatever x plus 1, right? That's why you've got. Now, just like I told you that, if there is like x is equal to y, then you can say log x is equal to log y. You can do that. Similarly, if you have, let's say, log a is equal to log b, then you can write a is equal to b, because simple log a. But here it's like 2 here. So can I write this 2 to the power? Because if you do that, then it would be like log this is equal to log x plus 1 whole square. Now, because there's something log this side, so you can.
Mhm.
So therefore, these two numbers would be same.
Yes.
Yeah.
I was thinking if I took a 2 out from that first quadratic and divided it just to make the numbers easier. But
You mean
like
because,
you know, because I've got 36 minus 30x plus 6x squared.
yeah, but that is within the log, and this is outside the log. These two, so you can't divide the whole both side by 2. But there it would.
So,
you can't divide here by 2 because
so I
there's a
can't
log.
divide that by 2 and put 2 there.
No. Because then anything which has to come from this side will go into the power. That's a power. That's a
Yeah.
property
Oh
of the
yeah,
log.
yeah. Okay.
Yeah. So you can't just move 2 in here.
Okay. So if I square the right bracket.
Yeah.
Okay, so then we've got 36 minus 30x plus 6x squared equals x squared plus 2x plus 1. And now we
Now you end up
solve
with a quadratic, probably.
Yeah, let me just do this one. Yeah. Oh. Let me double check. Yeah, I got it. So it's x is 7 over 2 and 5. That's what 7 over 2 would make it. So, oh. I think I did it wrong because I got 3.5 and 5 basically.
Is it?
Yeah.
What was your wait? This side was 36.
Oh no.
Minus.
Sorry, I got 7 over 5, which is
30x plus 6.
I got 1.4. Yeah, I got one answer. I got one.
Yeah.
Yeah. Yeah, so my brackets were. So I got 5x squared minus 32x plus 35.
Yeah.
And 5x minus 7 and x minus 5.
Yeah. So you'll get just once because your range is. No, that's what here.
Uh-huh.
Okay. Next.
Yep. So we need to give the answer in that form. Okay. So is it like x equals that?
Well, yeah. When you simplify, you'll get x equal something like that.
Okay. Okay. So if we do log, so those are like, so it'd be like x log 2 plus 3x plus 1 log e, which is 1, right? Equals log 10.
Yeah, you take, yeah, it's just like this one, the one we did here, number.
Yeah.
Yeah, exactly like that.
So I've got x log 2.
Yeah.
Plus 3x plus 1.
Yeah.
Equals log 10.
Yeah.
Okay. now. So
So you have to find x.
mhm. Oh,
So if you take x common, you'll get 3 plus log 2 is equal to, I can say, -1 plus log 10. No, I can write like that. So there x is equal to -1 plus ln 10 over 3 plus ln 2. And exactly we have found the solution in this form. So if you want A, B, C, D, so A is -1, B is 10, C is 3, and D is 2.
how did you get from step 1 to step 2?
From there to there.
Yeah.
Okay, so look, this is look. So first of all, what I did, move this +1 to the left hand side, so it's got here. And if you look at here, I can take
of course,
x.
yeah.
Yeah, I think it's simple. I mean, rearranging equations. If you take x common, so it's like 3 plus log 2. No, I just took 3 common from here. Sorry, x common from here. So x common.
Yeah, the next is yeah, I got it. Yeah.
Just
It
rearranging.
was what's the word? I didn't recognize this to be able to as soon as I'd moved to the other side, I could do it.
Yeah, exactly.
Oh,
Wow.
so then it asks it in that form. So if
Yeah.
I just
I did not use calculator because you have to write your answer in this form. You know, that's fine.
so log 10 minus 1 over log 2 plus 3. So it uses ln here, but we're using log. Is that the same thing?
Well, generally, you know, it's like, oops. So when the base is e, we call this as a ln. Simply you can write ln. But if your base is let's say log base 10 or log base something else, then yeah, we have to write like a log. But when you write ln, it means naturally the base is e. So ln is actually this.
Okay.
So base is always e. That's what we call natural log. Yeah.
So I could just change the logs for ln.
Oh yeah, that's what I wrote here. Look, because that's why I mean, if you don't write anything, it's assumed that it's always e here. You know, it's like e here.
Okay.
Generally, we don't write.
And so log of 10 is different from log of e.
Oh, of course, yes. Let's say I'm saying, okay, tell me what is natural log of 2 is not same as, I mean, it would be different as log of 2 with the base 10. So here it's base e, and here is a base 10. So they're not same, they're different. I mean, even though you're taking log of same number, but if the base is different, the numbers would be different.
Okay.
Yeah.
Got it, yeah. That was the number 3. Now this is the stuff we started to do in class. So this will like be on my exam basically. So y equals f of x, we just draw that.
So you have to sketch the curve with the equation y is equal to fx. So simply you have to draw the graph of that, yeah.
So with these transformations, do I do this bit first or the times?
No. The first you do the times, because that's the first one attached with the exponential. So you're actually, your key thing here is exponential x. The first step what you do is you draw this graph 2 times e to the power x, and then the second step you do transformation of this, and then you subtract this by 5 unit. So the step 0 is draw the graph of that, then draw the graph of that, and then draw graph of that.
Am I supposed to know what this looks like?
Do you know what it looks like? So
Is it?
is
It's
it
like this is
like this? No.
Oh.
That's ln. What you did was ln. So this
Oh.
is, you know, we say that exponential increase. So it's like exponential graph, and it increases like exponentially.
Okay. So then, if it's times 2, it's
So if you just times that by 2, so what will happen? So
times 2 in the y. Yeah.
Yeah. So what will happen? Basically, because this is 1 actually. So because it is increasing, so if you times, then it will be like more sharper like this. And at the bottom here, so if I have to draw this in the same graph, it'd be like this, above here, but below this. Because it is below 1, so if you multiply by 2, it will basically decrease further, and it will increase further. So basically, it's the same graph, but it's just more steeper. So this is now 2e to the power x. Yeah, and then here it is -5. So when you subtract -5, then actually you pull the graph and just shift everything by 5 unit below, by -5, isn't it? So if this is 1, so your new graph will be somewhere here with the -4, isn't it? Because you are moving everything by 4 unit. So graph will remain exactly same, but it will be just like, you know, and it will approach which value?
-5.
-5. So that's your final graph.
Okay. Got it.
If on the contrary, let's say if it was +5, then obviously you will move the graph 5 unit up. Yeah. So this is how we do transformation of graph.
Okay. Got it. And so for the next one, so this is like modulus of a graph. So every bit that's negative becomes positive, right?
Positive, absolutely.
So would it be something like that?
Yeah, exactly. Just you take the mirror image, but only of the negative values. So basically, it will be like just mirror image of that. This one.
Yeah. And
so what would be that point? Can you guess?
4.
4.
5.
No, 4.
Well, yeah, 4 then 5.
4, and then it will approach to 5. That's what. Yeah.
Okay.
So that's it. So look, it says that on each diagram, state the equation of asymptote. So this is called asymptote. So here we have already drawn that. So it's like x equal to -5 in this case, and in this case x equal to 5.
Is it not y equals 5?
Sorry, yeah, you're right. Y is equal to 5. Y is equal to 5.
And is that, oh, it's 6 marks for all of that. Okay.
All of that, yeah.
Okay. What does that mean?
So basically, there are two different functions. The one is modulus of fx, and another one is just fx, right? So you have to simplify that. All values of x.
There's 1 mark, so it's quite easy.
Mm-hmm.
Not much work, but so am I finding like this point?
Well, you'll have to see where the two graphs. The one you draw the graph of that, and you draw the graph of this one, right? And so, yeah, so that's the point where they are meeting. They're equal, isn't it?
Yeah.
So it's like answer is there are two sets of answer, because from here onwards they both are exactly same, right? This value.
Yeah.
Your answer would be for all x greater than this value.
What value is that? Can I,
For that,
I mean, can I use this and like equal it to
mm,
0 and solve
uh,
for x?
no, not equal to 0. So what happens? So it would be twice e to the power x minus 5 is equal to minus 2 e to the power x plus 5. So it will be 4 e to the power x is equal to 10. So you'll get e to the power x is equal to 2.5. Yeah. And then x would be, if you take log both sides, that would be that would be this value.
I got the exact same with the way, so you know the way I said it with so this is the equation of this, right? Then if we equal that to 0 because y is 0.
Yeah.
Yeah, I got that.
Yeah.
So there's two ways of doing it.
Doing this. Yeah, so that's also right. What are you saying? Because basically this is where it is 0. Right? But you can do only when you can see the graph. So you can see that graph, yes, this is the point where they're meeting. So let's say if you have not done the graph, then yeah, you need to do this way. But yeah, I think you're right, and you can do in this way as well. So just put that equal to 0, you'll get that value. Yeah.
Okay, and so this was the one we drew in yellow.
We drew in yellow, yeah.
And this
is
one,
the one,
so it's
the
like,
one in here, this one, the one we took reflection.
Okay, so this is reflected in x.
Yeah.
This first. Then it's moved up 5.
Yeah.
Okay. That's those. The range of f. Okay.
The function f and g are defined by f of x. Yeah. G of x is ln x. Okay. State the range of f.
So is that like the y values?
Exactly. The range is y value and the domain is x values. So
Y. If I. So there's one mark again.
yeah.
Y values would be when x is 0, right?
No. All range means all possible. So whatever. Sorry. So a range means whatever. So this is a function. Let's say. Let's say this is a function f of x is equal to e to the power x, for example.
Yeah.
And I'm saying that, okay, tell me what is the range of this. A range means for all values of x, whatever you put the value of x, that means for all domain of x, what is the maximum and minimum values this function can take. And now you can see here, if you see the graph, that's the graph of exponential x. That means it starts from limiting from 0. The y value approaches to 0 after very, 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 very small values of x, and it goes to the positive x, positive y, infinity y. So the range here for this graph is y is greater than 0 always.
Oh, greater than when x is 0.
No. When x is 0 is y is equal to 1. This is this point.
Yeah, so as long as it's above that, is that what?
No. That's also, it also takes this one. So range means all possible values of y. So it's like, like this. So it starts from 0 and goes to the plus y, infinity here. So all y greater than 0. So that's a range. Because it never goes below the y 0, and it never takes a negative value. So that's your range for this graph.
Got it.
Now, what about this one then? So e to the power x is this graph. So this is 3. And asymptote in this case would be 2. Yeah. So in this case, the range would be all values greater than 2.
Okay.
That's the answer.
Okay, that wasn't that bad. Okay. So f of g of x. So f of x is that. So f of x is that.
Mhm.
Then f of g of x means that we do f of g of x equals e to the ln x
Plus 2.
plus 2.
Yeah.
Okay. Okay.
Now it says give your answer in this simplest form. So e to ln x.
Is it just x plus 2? Like, do those cancel, ln and the e?
I am not 100% sure on this. I think it cancels, yeah, because e to the power ln x is actually x.
So x plus 2.
No, I would say no, because e to the power ln x 0. No. You leave it like this only.
Okay.
So therefore, e to the power ln x is not x. Yeah.
Okay.
So that's your standard form.
Find the exact value of x switch for f of 2x. Okay, so so is it like e to the 2x plus 3
3, yeah.
plus 2 equals 6?
Yeah.
Okay, then so with e, if I do 2x plus 3 ln, well, plus ln 2 equals ln 6, if we bring everything down.
Say again, what did you say? Say again that step.
So we had e 2x plus 3 plus 2 equals 6.
Yeah.
Then I ln, I did the natural log and got 2x plus 3 plus ln 2 equals ln 6.
No, that's what I said to repeat. Okay, so let me write there. So you got actually e 2x plus 3 and plus 2 is equal to 6. That's what you got, right?
Do I log it? Like,
Yeah. So yeah,
yeah,
that's it, is it?
yeah. If I log it, I could do it. Yeah.
I mean, say, so I'm just trying to figure out your mistake, what you did. So if you take log both sides, so you can't do like this. So e to the power 2x plus 3 and then plus 2. Like it's like this. So let's say if I have a plus b is equal to c, right? And I'm saying take the log both sides. So you said log a plus log b is equal to log c, right?
Yeah.
That's wrong. That's mistake. No, that you can't do that. You can do like this. So you can do log of a plus b is equal to log c. That's the right way of taking log. But you can't break this.
Okay.
Yeah. So this is wrong. This is mistake. So here, rather than taking log now, you can write like this. So you can say, okay, e to the power 2x plus 3 is equal to 4, isn't it?
Oh, I don't even think of that. Yeah.
Yes,
So
I mean, very natural thing because like plus 2 here, so that's it. And now you can take easily log. So it's like 2x plus 3 is equal to log 4, isn't it?
Yeah.
And now you can just simplify this.
Okay. So if I decided not to move that to that side,
Then
so is it like so I have to like log that?
Yes. Yeah. And which is of no use because then what would you do then in next step?
You can't do anything.
No, you can't do anything. So that's what I'm saying that.
Okay. There's only one way to do this.
Yeah, that's by the, yeah, that's only one.
Then we just solve for x.
You can solve for x here now.
Find inverse f of x.
Yeah.
Inverse continuous domain. Okay. So with the inverse of a function.
So here you change the subject actually. So how do you find the inverse? So this y is e to the power x plus 2. That's the function. You have to find inverse. So rather than fx, I'm just writing y. So change the subject. Like, probably you would have studied this in GCSE. You're changing the subject.
If we do x equals e to the y plus 2 and we solve for y. Yeah. So x minus 2 equals e to the y. ln x minus 2 equals y.
So it's y minus 2 e to the power x. So therefore x becomes ln y minus 2. Yeah. And therefore, so f inverse x therefore becomes ln x minus 2. So that's your inverse function.
X minus 2.
Now what it's saying? It's saying that stating its domain. So domain, you can see here x minus 2. So x minus 2 must always be positive.
So
you know
y
why?
is, so it's like to the greater than 2.
Yeah, so x would be greater than 2. So that's the domain of this new function. X must always be greater than 2.
Okay.
And do you know why I did that?
Because it's like x minus 2. Sorry, it's y minus 2 in the bracket. Well, because in the bracket it's
because when you take ln of any number, this number cannot be negative. So log of negative numbers are not defined. So this number should always be positive. So that's what I'm saying, that x minus 2 should always be greater than 0.
Okay.
If you remember the graph of log x, it's like this. So this is always, so this is ln x. So this is always, so you'll see there's no graph for the negative value of x. It's only for positive values of x. This side only, positive values of. So because a log of negative numbers are not defined.
So is that a 1? Well, yeah.
Yeah.
So the exponential one's like that.
Yes,
like
absolutely. That's why this is the reflection across the line y is equal to x, and that's why these two are the inverse functions of each other. Any inverse function is always reflection with respect to the line y is equal to x.
Always.
Yeah, always. So any function. So if you want inverse, it will always be a reflection across y is equal to x.
Okay. What was the domain? And we just did this one. Well, we didn't.
Yeah, you can just
do that.
So it's basically drawing the both. I mean, if you've done that, did that. So strangely, there's nothing about gx here. It says that there's a function called gx, and there's no question on gx.
Yeah, good point. Well,
there's one here. Yeah, okay.
Yeah. I think I can do that. So I can do the first bit.
The range of f here.
Actually, no, let's go through it all. Never mind, this is hard.
I don't think it's easy, even though it's 1 mark, but
the range of f.
It is easy, but
is there an easier way of writing this? Like from looking at e to the 2x plus k squared, I can't figure out the range.
Look, it's easy because why I'm saying it's easy because this, look, exponential to any power, whatever it is, x, 2x, 3x, 4x, whatever. So here it is 2x. This function, like e to the power any number here, the range, the graph is always positive like this. So the range of this function is always greater than 0, right?
Oh, so that's the answer.
No, but then you're adding something here. So you're adding what? K squared.
K squared.
So therefore, the range would be, because it's a 0 here, so just add k squared here. So it would be always above. So you just shift the graph by k squared. So I'm going to shift this by like k squared here. So this value would be k squared. So the range, new range would be greater than k squared. K is whatever. It's just a positive constant. So yeah.
Okay. And do I have to put y is greater than k squared, or is it r?
Yeah, you can either say like a range of this function f. So we write like range of the function because function is defined like here. It automatically means that you're talking about y value, because when you say range always talks about its y value. When you say domain is always about. So this is actually domain. This is range. This is the original when the functions and everything was defined. That's the original thing. Then later on, we defined domain as x and we said range as y. So if you write domain, yeah, and if you write range, it automatically means that, yeah, it's y value. Or you can write like this. No, it doesn't matter. You can write like that in a more simplistic thing. Yeah.
And if we do the inverse like we did there, so e to the 2y equals k, well, plus k squared equals x, and we solve for y.
Yeah.
E to y equals x minus k squared. 2y equals ln x minus k squared. Okay, so we have ln bracket x minus k squared over 2.
Yeah.
So the domain is, so that bit has to be positive. So x minus k is always greater than 0. So x is greater than k squared.
Yeah, that should be the domain then.
Okay.
Part C.
Solve. So we solve for x.
Yeah.
So g of x is a function. Can I replace g of x with x for now? Then sub in later.
Yeah, don't say x then if you're replacing. Say use some other variable.
Y. Let's go y. So g of x equals y.
Yeah.
So y plus y squared plus y3 equals 6. So y equals y squared plus y equals, so I have to solve for y here.
Yeah.
How do I do this?
Well, I would say start using the functions first. Look at the function, right? So look at the gx. So gx is this. That's fine, right? Now let's see g of x squared. What is g of x squared?
We have to use that.
Yeah. Well, yeah, of course you have to use that
That
function.
makes so much sense now. Yeah. Okay. Yeah.
Yeah. Otherwise, you don't know what is gx, no? So g of x is given to you. Now you understand?
So okay, yeah. Oh my god, that makes so much sense because I was stuck with y plus y squared plus y cubed equals 6. And I couldn't
No. You
do
just
anything. So ln 2x. So that's g of x.
yeah,
Plus ln of 4x squared.
not 4x squared, 2x squared, because it's x squared only,
Yes. Just the x squared.
just the x squared. Yeah.
Plus ln 2x cubed
Yep.
equals 6.
6. Yeah.
Okay. I'll take L. Can I take L on common?
No, that's the thing.
No.
Again, you can, remember I told you, ln
Yeah.
is not a variable.
Yeah.
So now here you can use property of ln. So ln A plus ln B plus ln C is equal to ln A, B, C. So you can multiply
Yeah.
that.
8x to the 6.
Yes, correct. So
Equals 6.
ln 8 e to the 6. Sorry, what I'm doing. ln 8 x to the 6, right?
Yeah.
Is equal to 6.
Then 8x to the 6 equals e to the 6.
Yep, that's good.
Therefore, well, because there's a 6 on both sides, so there's an 8 though.
So x to the 6 is e to the 6 over 8.
Yeah.
Then use your calculator to find. So your x therefore would be e to the 6 over 8 to the power 1 over 6. No, because it's like x to the power 6 here.
Yeah. Then a calculator.
Yeah, you'll have to use calculator to find the exact decimal values here. Or if
Can
you
you
want
do
to
that in your head?
Oh no, it's beyond anybody's. It's because it's first of all it's exponential 6, which is very large number, and then you're dividing that by 8, and then you're taking square a root of 1 over 6. So
it's impossible.
yeah, so exponential 6 is almost like more than millions or whatever. So, so it will be somewhere here, maybe, I don't know. So it's just
I got 1.9. Oh, simplest form. Do you think I have to find? If I just leave it like that,
I think that's what I was thinking, because it says that in the simplest form. So that's the simplest form. You don't have to, find the decimal value. That's the simplest form.
Find that in its simplest form. So we put g into f of x. So
yeah,
e to the 2 times ln 2x.
Yes. Plus k square.
Plus k squared. And that is f of g of x. Yeah. Oh, that first bit looks. Well, that's times. So there's an e to ln 2x. At the moment, I've got this, like, I've just subbed it in, so I'll have e. I've got 2 ln 2x. But this is in brackets too, right?
Yeah. I'm just finding something interesting. Right. Okay. So I've just found from Google, which I was not sure, and I can confirm now, is this that it's a property which you can use. So e, oops. So e to ln x is actually x.
Yeah.
Yeah.
Oh. Okay.
Yeah, it is. It is. Yeah. So I thought that it is, but I was not sure. So I just checked Google. It is correct. So that's correct, right?
Okay.
So e to the ln x is x. So now what you can do, look carefully. Your equation, where is that? What we were doing is f of g of x, right? So
Yeah.
f of g of x is e to x is what? So it's ln 2x. So ln 2x. That's what it is. Yeah.
Yeah.
Which is this much. Correct. Now
Mhm.
here, can I shift this to this here? So therefore,
Yeah.
can I write e to the power ln 4x squared?
4x squared.
Yeah, because
Plus
it's like 2
times-
log a. I can write is log a square, isn't it? I can write like that.
Oh yeah, because you move it to the front. Yeah.
Yeah,
Yeah.
because we move the power to this, it goes there.
How is
That's
this
what
a
I'm doing.
4 then?
Because it's ln 2x whole, whatever is inside the whole square, isn't it?
Yes.
You know,
Yeah, that makes
that's why
sense,
it's whole square. Now, look, e to the ln is 4x squared. So this actually becomes simply 4x squared.
4x squared equals k, well, plus k squared.
Oh, did we miss something except k squared? Yeah.
Yeah, that's k squared. Yeah.
So it's just like k squared here. Simply k squared plus k squared. The important thing here for you is to this one. Just remember this one. So e to the ln x is actually x. And for me as well, because I was not pretty sure about this. Yeah.
That's that.
Yeah.
Constant k to the solution. If we go, yeah. So what we got for f of g of x was 4x squared plus k squared.
Yeah, simply put that is equal to 2k squared, and you can just solve for x.
Yeah, 2k squared. Oh, so 2k squared minus k squared equals 4x squared. K squared equals 4x squared. K equals 2x. Also, find in terms of the constant k.
Yeah.
So
to find
is k
to find
equals
x.
2x? If I should find x.
Oh yeah, it says that find the solution. So whenever it says solution, means you have to find the values of x.
Okay, I got k over 2.
Yeah, so that's it. That should be the answer.
Right out the area of the culture at midday. So midday is 12 hours, right?
Yeah.
So, t hours after midday.
Oh, does it
So if
say?
we put, well, because it says at midday and t hours like after midday. If t is
Well,
0, it's midday, right?
2 hours after midday. Yeah.
So if t is 0, a is 20.
Yeah.
Okay. Find the time at which the area of the culture is twice the area as it is midday. Okay, so we want the area to be 40, correct? So 40 equals 20 e 1.5 t.
Yeah.
So 20 equals e 1.5 t. So ln 20 equals 1.5 t. T equals ln 20 over 1.5. So I've made a equal to 40, like twice our answer in part A.
Yeah. And then just solve
Solve
for t.
for t.
Yeah.
Yeah. So if I make t 0 here, it'll be 20.
No. Yeah, you're right. You're right. Because e to the power 0 is 1, so 120 minus 100 is 20.
What's this lambda here for?
It's just some constant.
Yeah.
Does it say something here about lambda? Find the
It
exact
doesn't
value of
mention it.
lambda. No, it says in part B, it is asking find the
Oh.
value of lambda here.
Okay.
So not relevant for part A.
So and the Ketzler is 70 degrees. So yeah, so 70 equals 120 minus 100 e to the minus lambda 40.
Yeah.
And we solve for lambda.
Lambda, yeah.
So if we do 50 equals 100 e to the minus lambda 40, then we divide that by 50. Yeah, so 1 equals 2e to the minus lambda 40. I got 0.01.
No, you have to find your answer in this form. You don't need to.
Oh, that one.
Yeah.
Oh, I did get that. Yeah, I got minus ln 0.5 over 40.
Yeah, that's it. Yeah, that because you don't have to find it exact like in decimals. So when T is capital T, the temperature of water reaches 100 degrees, the kettle switches off. So capital value of T for the nearest whole number.
Okay, so we just got lambda.
Oh. Yeah.
Should I
Oh,
calculate lambda as a decimal value to make it easier? So I can sub it in.
Yeah, but no, because here you calculated the lambda for 70 degrees, and here it is asking for 100 degrees. So you'll have to do the same thing for now for 100 degrees Celsius.
So just to get the concept, so I sub in 100 here.
Yeah, here. Then
I solve for lambda. Then I do again 100 mile value of lambda and t, and solve for t.
No. You'll have to use the same lambda because I can see this question is relating. Yeah. So whatever you got the lambda in this, put that in this question. And it's just that the temperature now is 100 degree, and you'll get the
so equal it to 100.
Yeah, equal to 100, and then you'll get the temperature T.
Yeah, that makes sense. I mean, if it was 2 steps, like I said, it'd be a little more than that.
Yeah.
Definitely. Okay.
Right.
I mean, we can probably do this next time. Only a few more questions. These are the hard ones as well.
Yeah, no worries. We will do all this thing. Yeah. So next time is New Year Eve. So which is 30? Is it? Oh, no. Let me see. When are we meeting? No. So, yeah, this Friday, right? So this Friday is 31st. I'm okay for 30th if you want, or maybe next week, say, let's say,
Up to you. Whatever.
or if you're okay, 30th, maybe 2 days after 2 days, Thursday or
Thursday.
Yeah, this Thursday.
This Thursday. Yeah, that's fine. Yeah.
This Thursday, same 7 to 8.
Yeah, I'll set that.
Yeah.
In. So. 7 till 8. Okay, that's fine. Okay, got it. Okay then, take care of
All right, then you
yourself.
take care. Yeah, and I'll
Yeah.
see you